In this objective, we're working on hypothesis tests for both the correlation coefficient and the regression coefficient in a regression equation. And so you're actually going to get two different types of questions in this ALEKS objective. So starting with this one, when you're given a least squares regression equation, the hypothesis test is about whether the regression coefficient is significantly different from 0. Okay, so in this case, we want to check our null hypothesis is always going to be that beta, which represents the regression coefficient, is equal to, and actually in this case they've given us beta sub 1, and so we want to be sure that we use that same exact notation. This is actually unnecessary because there's only one regression coefficient, but when we get to multiple linear regression, you're going to have multiple beta values, and so at that point it will be really important to always denote your betas with a subscript. But in this case, we'll do it beta 1. Our null hypothesis is that that coefficient is equal to 0, and our alternative or research hypothesis is that beta 1 is not equal to 0, so something other than 0. And we're actually going to use a t-statistic to test whether this is true. And our t-distribution is has an n-2 degrees of freedom. So if we read in the experiment, we have a random sample of 79 mice, and 79 minus 2 is 77. So we have 77 degrees of freedom. And we're asked to calculate the test statistic. So I'm going to give you the formula for the test statistic for testing this hypothesis. So our test statistic in this case is going to be the beta value from our equation divided by the standard error of that beta value. In this case, beta 1 is going to be equal to negative 1.59. And the standard error they've given to us is 1.17. This is equal to negative 1.35897. And you can see I always just carry my decimal places out way more than I need to. And it's asking for the value of the test statistic to 3 decimal places. So we'll end up putting negative 1.359. Negative 1.359. Then we are asked to find the 2 critical values at the 0.1 level of significance. And so we do this just the same way we would for a t-test. We want to find t remember that we have to divide that by 2, so t of 0.05 on 77 degrees of freedom, because this is a two-tailed test. Right, so we take our level of significance and divide it by 2 for a two-tailed test, t of 0.05 on 77 degrees of freedom. And so our lower bound is negative this number, negative 1.664, and our upper value is 1.664 positive. Actually, let's round that to a 5 at the end. And it says, based on these data, can we conclude, using this 0.1 statistic significance level, that there is a significant linear relationship between drug dosage and the heart rate of a mouse and an hour after drug ingestion? And so basically what we have to figure out is our test statistic greater than the cutoff values? And in this case, it is not, so we would say no. Okay, so this is the same question as we got last time, except that it's asking us to find the p-value. So we'll use the p-value calculator just like we always do. But remember, it's a two-sided test. So in this case, we want to find p of t greater than 1.596 on 62 degrees of freedom, and then multiply that number by 2 since it's a two-tailed test. And this would give us 0.116, and we compare that to our p-value of 0.05, and it's greater than that, so we would say no, we cannot reject the null hypothesis. This is the second type of question you'll come across in this objective, which is a problem where they found a correlation coefficient. And the good thing is we're also going to use a t-distribution to test the correlation coefficient significance. And so we'll have a t-distribution with n minus 2 degrees of freedom. And in this case, the t-statistic that we're going to be calculating is r times the square root of n minus 2 over 1 minus r squared. So a little bit more complicated math than we saw with testing the betas. And then for our null and research hypotheses, we're going to use the population correlation coefficient Greek letter to denote that in our hypothesis testing. So our null hypothesis in this case is that the population coefficient is equal to 0. And our research hypothesis is that it is not equal to 0, which is basically just to say we do have a significant correlation. It's above 0 is our research hypothesis, and our null hypothesis is that whatever correlation coefficient we found is not really different from 0. It doesn't really matter. In this case, we're going to be using a t-statistic with n minus 2 degrees of freedom. In this example, we have a sample of 95 students, so 93 degrees of freedom. 95 minus 2 is 93. And let's calculate the value of the test statistic. So I'll go through it with you step by step. It's a little bit tedious here, but we have all the information we need to do it. So 0.25 times the square root of 93, right? 95 minus 2 over 1 minus 0.24 squared. This simplifies to 0.24 times 93 over 0.9433, which simplifies to 0.24 times the square root of 98.59, which is 0.24 times 9.929, which is equal to 2.383. And now we need to find the p-value, and again, this is going to be a two-tailed test. So we find the probability that t is greater than 2.383 with 93 degrees of freedom, and we multiply that by 2. And so our p-value is 0.019. And it says, based on the sample results, can we conclude at a 0.05 level that there is a significant relationship? And because our number is less than 0.05, we would say yes.